When we think of mobsters, we often think of those associated with movie franchises, yet thugs are everywhere, right under our noses. They're taking over backyards, schools, parks and cafes. The spine bill dares not to sing anymore, nor the superb fairy wren to chirp as it digs around the garden. No. Instead, our peaceful ambience is being penetrated by the war cries of these armies. Yet, unlike Michael Corleone and his goons, these offenders are 60 grams of pure, feathery rage. They are, of course, the noisy miner. Noisy miners are quickly becoming one of our most successful avian species due to their ability to adapt to rapid anthropomorphic changes and, unfortunately, to harass and exclude other birds from already limited resources, sometimes even killing them. While current research efforts are focusing on finding a way to remove these tyrants of the sky, I am attempting to understand if, like your misunderstood antagonist, there is a reason the noisy miner is the way that it is. The ability to flexibly change behaviours, diet, and even breeding season suggests that noisies are capable of higher levels of cognition than we previously appreciated. As such, one aim of my PhD has been to understand what it could be about the brain of the noisy miner that allows these complex behaviours. Yet, we found, and evident here, that it likely isn't the size of their overall brain. In fact, noisies possess brains no bigger than that of a peanut, which is relatively small for a bird of their mass. Yet this makes sense, as noisy miners are essentially Happy Meal size to birds of prey, and their lifestyles actually depend on them being agile during flight. So instead, we have theorized that to lighten the load, the brain size in these birds and similar has been reduced, yet the number of neurons has remained consistent or even increased to allow for a higher neuron ratio. But testing this theory wasn't easy. Previous methods to quantify neuronal density were either laborious and at risk of human error, or they simply gave numbers rather than both qualitative and quantitative information. Therefore, we built upon these methods to develop a new approach that uses flow cytometry to not only quantify the number of neurons present in distinct regions, yet to also understand the composition of the brain as a whole. To develop this protocol, we trialled it in Worcester rats due to their neuron counts already being estimated thanks to their important role in medical science. However, now that we know this protocol is successful, we are using it to understand the neuronal makeup of the noisy miner, to compare the information about their brain to their behaviours in an attempt to understand if noisies are bad to the bone or simply bad to the brain.